For all of human history, the moon has been our silent companion in the night sky. We've gazed at its marbled face, written poems about its light, and spun stories of the man who lives there. It has guided sailors and inspired dreamers, but its true nature remains mysterious. The moon is a world of silence and stark beauty, a place without wind or weather, preserving the secrets of our solar system's birth. We thought we knew the moon, after all we've walked on its surface and brought back its rocks. The Apollo missions gave us a glimpse but also revealed how much we still don't know. The moon's two faces are a perfect example. The near side is smooth and dark, while the far side is ancient and rugged. Why this stark difference? This puzzle hints at a complex history we're only beginning to understand. Every new mission adds another piece to the puzzle, showing us the moon is far more complex than we imagined. We continue to look up, not just with our eyes but with robotic explorers. These machines brave the vacuum and cosmic radiation, reading the stories written in lunar dust. The moon is more than a rock. It's a library of cosmic history and a potential outpost for humanity's future. And as we're learning, it still has the power to surprise us. Our closest neighbor is not just a relic, but a world with secrets waiting to be uncovered. Each discovery reminds us that the universe is always more wondrous than we expect. The moon's silence is not emptiness, it's an invitation, and we are finally learning how to listen. For decades, space exploration was a two-player game, the United States and the Soviet Union. Their race to the moon defined an era and set the stage for all that followed. But the universe is vast, and new voices were bound to join. In recent years, China has emerged as a major force in space. The China National Space Administration, or CNSA, has moved with patience and ambition. They learned from the past, building their own rockets, space stations, and vision for the future. Step by step, they launched satellites, sent humans to space, and built the Tiangong space station. Each success built confidence and capability, allowing them to look beyond Earth. Their gaze, like the pioneers before them, turned to the moon. But China didn't just want to repeat old missions, they wanted to explore new frontiers. Their goal, to visit places no one had gone before and answer questions left unresolved for decades. With a clear, long-term strategy, China has become a leading force in 21st century space exploration. A new voice has joined the cosmic conversation. The world is watching, waiting to see what secrets this new era of exploration will reveal. The story of the moon is no longer told by just two nations. It's a global endeavor, and the next chapter is being written now. China's lunar program is named after Chang'e, the moon goddess, a fitting symbol for their careful, ambitious missions. Chang'e 1 and 2 orbited the moon, mapping its surface in unprecedented detail. These missions paved the way for a bold step landing on the surface. In 2013, Chang'e 3 touched down on the near side, deploying the U2 rover. This was China's first lunar landing and the first by any nation in nearly 4 decades. But the real ambition lay on the far side, a place no one had ever landed. To reach it, China launched a relay satellite, bridging the communication gap. In 2019, Chang'e 4 and the U-22 rover landed inside the South Pole Aitken Basin, one of the oldest and largest craters in the solar system. This site could hold clues to the moon's deep interior. U-22 has been exploring this ancient basin ever since, sending back images and data. It was during this patient exploration that U-22 detected something unexpected, an anomaly that would capture the world's attention. The moon was about to reveal a new secret. Imagine being a rover, rolling across a landscape untouched for billions of years. Day after day, your instruments detect the usual lunar minerals until one day, something different appears. The spectrometer picks up a signal that doesn't fit a mineral that shouldn't be there. The data is checked and rechecked, no malfunction, no mistake. U-22 moves closer, analyzing a cluster of crystalline rock fragments. The readings are confirmed, this is a true anomaly. In Beijing, excitement builds. This is the moment every explorer dreams of. The rover hasn't just found another rock, it's found a question mark in the lunar soil. What is this material? Where did it come from? Its presence challenges our understanding of the moon's formation and history. Scientists work quietly, verifying the data before making any announcement. When the results are finally shared, it's clear, the anomaly is real. The moon has just rewritten part of its own story, and the world is listening. After months of analysis, the mystery mineral is revealed, kyanite. On Earth, kyanite is a blue silicate mineral common in metamorphic rocks, but on the moon its presence is astonishing, like finding a penguin in the desert. Kyanite forms under immense pressure and high temperatures, conditions thought impossible on the moon. On Earth, it's created by plate tectonics, something the moon supposedly lacks. So how did kyanite get there? One theory: the ancient impact that formed the South Pole Aitken Basin generated enough heat and pressure to create kyanite. Another kyanite was already deep inside the moon, excavated by the impact. Either way, the discovery suggests the moon's interior was once far more dynamic than we believed. It hints at a hidden geological history, waiting to be uncovered. The moon, once thought geologically dead, may have been much more alive. And this single mineral is the clue. The discovery of kyanite is more than a curiosity, it's a window into the moon's past. Kyanite's presence means this region once experienced extreme pressure and heat. This challenges the simple view of the moon as a geologically dead world. The prevailing theory says the moon cooled and solidified quietly, but kyanite suggests a messier, more active history. It points to processes that could have buried crustal materials deep inside, or created high pressures through unknown means. The implications go beyond the moon. If impacts can create kyanite here, similar processes may have shaped Mercury, Mars, and asteroids. This single find opens new avenues for planetary science. It's a reminder that our models are always incomplete. Nature is more complex than we imagine. The moon, once thought simple, is full of surprises. Science thrives on these moments, when a single discovery forces us to rethink everything, and the search for answers has only just begun. This discovery isn't just scientific, it could shape humanity's future on the moon. Building lunar bases will require using local resources, not hauling everything from Earth. Kyanite is an aluminum silicate, a potential source of aluminum for construction. More importantly, its presence hints at a complex lunar geology with concentrated mineral deposits. The moon may have resource-rich zones, making mining for metals and rare elements more feasible. The processes that formed kyanite also suggest a history involving water, perhaps more than we thought. Water is the holy grail for lunar explorers, vital for life and fuel. This new understanding will change how we plan missions and settlements. Future explorers will become prospectors, seeking out these complex terrains. The U-22 discovery may have pinpointed the site of the moon's first industrial park. The path to a self-sustaining lunar presence just got clearer. A discovery like this has global implications. It raises a question: will our journey to the moon be defined by competition or by collaboration? The first space race was a rivalry, but today, space is a crowded field. Nations and private companies are all reaching for the moon. The potential for a new space race is real, but so is the need for cooperation. No single nation can do it all alone. The International Space Station proved what's possible when we work together. Could we build an international lunar base combining the strengths of many nations? Scientists worldwide are already collaborating on U-22's data. The discovery of kyanite could be a catalyst for unity. We face a choice: retreat into silos or reach for the moon together. The future of space exploration depends on the path we choose. What does it all mean? A tiny rover finds a blue mineral on the far side of the moon. It may seem small, but it unlocks a new chapter in our understanding of the cosmos. The moon is more dynamic and complex than we ever knew. This is why we explore, not just for technology or prestige, but because curiosity is part of who we are. The story of U-22 and its discovery is a human story, a testament to our ingenuity and drive. Every image and data point belongs to all of us. The journey is far from over. There are more questions than ever. We must go back, send more advanced rovers, and eventually send people to walk among those ancient craters. The moon is waiting, holding more secrets. The universe is whispering, and we are finally learning to listen. Thank you for joining us on this journey. If you found this exploration fascinating, please show your support. Like this video and subscribe to Cosmic Discover for more stories from the frontiers of science. The next voyage into the cosmos is just beginning. Stay curious.